Hi everyone, and welcome to The Sleepy Scientist. I'm really happy you're here. Tonight, we're going to go on a calm and quiet trip to learn something amazing. So get comfy, take a deep breath, and let's enjoy this peaceful science story together. Before we start, tell me in the comments, where are you watching from and what time is it for you right now? If you like relaxing science videos, don't forget to tap the like button. Now let's begin. Imagine a clock floating in the quiet void of space. Not ticking loudly, not hanging on a wall, but drifting gently, untouched by wind or gravity, as still as thought before it forms. Now imagine a second clock, identical in every way, but this one is attached to a spacecraft, humming softly as it glides through the dark. At first, both clocks tick in harmony, 1 second, then another, perfectly in step. But as the ship begins to move faster, strange things begin to happen, not suddenly but subtly, like the hush before snow begins to fall. Time, the quiet ruler of everything, begins to bend, to stretch, and to slow down. Not in the way we feel when we wait for someone, not in the way a child waits for morning on a birthday, but literally, physically, measurably, time starts to change its shape. This isn't a story of fiction or dreams, it's real. It's the heartbeat of Einstein's theory of special relativity. As a traveller moves closer and closer to the speed of light, that sacred boundary in the universe, their time runs differently than yours, slower, quieter, almost like a whisper fading into stillness. This is not a trick of the eyes or mind. It is a law written into the very fabric of space and time, that when motion increases, time decelerates, gently, invisibly, but surely. Now drift for a moment into this thought. You are that traveller, inside a ship racing toward the light, looking out the window at a universe that begins to stretch like silk, pulled between fingers. Galaxies begin to smear into ribbons. The colours shift, reds deepen, blues vanish. Outside your window, stars live and die in a blink, while inside your heart still beats slow and steady, as if the universe hasn't noticed your motion. But it has. It always does. Scientists call it time dilation, and though it sounds sharp and mechanical, it is, in truth, something soft and humbling. It's as if the faster you go, the more time lets you go gently, as if it's reluctant to pull you forward. A clock aboard your ship will tick more slowly compared to one resting on Earth. If you travelled for what felt like a single year near light speed, decades could pass behind you. You would return younger than your twin, not metaphorically, truly. This is not a fantasy. This is how our universe works. It's built into the equations, into the very way light behaves, into the invisible currents that hold the stars in place. Now imagine light itself, not just as a beam or a flash, but as the universal boundary, the grand limit of motion. Nothing with mass can catch it, not because we lack engines strong enough, but because nature herself has drawn a line. The faster something moves, the heavier it becomes. As you approach the speed of light, your mass stretches toward infinity. You would need infinite energy to move just a little faster, and so light remains the unreachable pace, the perfect rhythm that no drum can beat. But light is also strange. It always moves at the same speed, no matter how you chase it. Whether you stand still or race toward it, it will pass you at the same velocity. As if light exists outside the rules you know, obeying something deeper, more poetic than logic alone. This leads to a curious question. What does time look like for a beam of light? If you could become light, if you could ride a photon like a surfboard through the emptiness, time would disappear completely. From light's perspective, no time passes at all between leaving a star and arriving in your eye. That journey, which may take millions of years for us, takes no time at all for the photon. It is born and arrives in the same breath. This isn't just an odd idea, it's what the math tells us. The universe is not just vast in space, it is layered in time, and the faster you move, the more those layers bend. The traveller at near light speeds lives in a different rhythm. They see stars age quickly, they see history unfold in moments, but they themselves stay slow, calm, preserved, like a memory untouched by the turning world. Now picture a satellite orbiting Earth. On board are atomic clocks, some of the most precise ever made. Down below, identical clocks tick quietly in labs, but they don't tick in unison. The satellite's clocks move slightly faster, not by mistake, but because of speed, because of motion. Time, it turns out, is not universal, it's local. It depends on where you are and how you move. This strange truth is why GPS works. If we didn't account for time dilation, your phone could tell you that you are standing miles from where you actually are. The satellites high above must whisper the time with such delicate correction, otherwise the maps would drift, like boats in a fog without stars. This is the gentle magic of relativity, not a spell, but a truth. That speed and time are lovers forever intertwined. One bends as the other flows, and the faster you go, the more time steps back. Like an old friend who knows you need quiet, like a breath that slows when you close your eyes, like music that fades at just the right moment. This bending of time is not some cosmic punishment. It's grace. It allows explorers to see far without aging fast. It allows the universe to keep its stories, even as it unfolds in rush and bloom. If we ever travelled far, really far across light years and stardust, we would see this in action. The ship's crew would experience only a few months, but the Earth they left behind would have aged. People would change, trees would grow old, cities would shift. Perhaps by the time they return, the world they knew would be gone, and yet for them, time stayed kind. So the next time you look at the night sky, remember this. The stars you see may no longer exist. Their light began its journey long ago. It has travelled across years, centuries, even millennia to find you. That light carries stories of the past, but it arrives now, in this moment. It is old, yet it feels new, because time at the speed of light is not what we think it is. It's both endless and immediate. It's both patient and gone, and as we walk slowly beneath the stars, it waits, quietly bending just out of reach, like the tale of a dream you almost remember. Now let's drift deeper, into the space between thoughts, where time and light begin to twist around each other like soft threads in a silent loom. Imagine yourself not just moving fast, but folding space itself with your speed. This isn't a fantasy, it's the gentle curve of relativity shaping your path. As you continue your journey near the speed of light, everything behind you begins to blur, and the future seems to stretch thin ahead of you. The universe, once so still and endless, now responds to your movement. Your velocity becomes a kind of key, unlocking hidden doors in the fabric of time. Scientists speak of space-time as a single sheet, not two separate things. Time is not a ticking clock above your head. It is a dimension, just like length or width or height. And light, always loyal to its speed, dances upon this sheet as both messenger and sculptor, shaping its curves, bending its threads, telling it where to fold. This means that the faster you move through space, the slower you move through time. They balance one another. If you could move through space at the speed of light, your motion through time would vanish entirely. You would be everywhere and everywhen, all at once and yet nowhere and never too. Let's float for a moment into the realm of paradox. Because what happens if somehow something could move faster than light? Not just nearly, not just approaching, but actually faster. Here we step into uncertain shadows, regions where our equations become strange and uneasy. Some physicists have dared to name these ghostly possibilities. Tachyons, they're called. Imaginary particles that, if they exist, always move faster than light. They cannot slow down below light speed, just as we cannot speed up beyond it, but with them time behaves in reverse. From our point of view, they would arrive before they left. Messages sent using such particles might reach their destination before they were spoken. This is the trembling edge of causality, the delicate thread that holds our understanding together. Because if effects can precede causes, if a reply comes before a question, then the world becomes mist. Order vanishes, logic sleeps, and yet the math permits it, not confirms, but allows, as if the universe is whispering that beneath its tidy rhythms stranger harmonies play. But perhaps faster than light travel doesn't require impossible particles. Perhaps there is another way, one that doesn't break the rules, but bends them gently like wind through tall grass. This brings us to the idea of warping space itself. Picture a rug laid out across a floor. You're a small bead rolling along its surface. Normally, to reach the far end, you must move across its entire length. But what if you could pinch the rug, bring 2 points together, and skip the space in between? This is the vision behind the Alcubierre drive, a theoretical model that suggests space ahead could be contracted and space behind expanded. Your ship would remain still, caught in a bubble, while space-time flows around it. From the outside, you would appear to move faster than light, yet you wouldn't be moving through space at all. Just like a surfer riding a wave, the water beneath them doesn't move them forward, they simply glide upon its rise. This bending of space, if possible, would allow us to cross vast distances without ever technically exceeding the speed limit. The light's boundary remains intact, but the path shortens. Time again reshapes itself around motion. But what of time itself? If we bend space, can we loop time? Some physicists believe that under certain conditions, space-time could twist into a loop, a closed time-like curve they call it. This is not a metaphor. It is a literal circle in the fourth dimension. If you were to travel along such a path, you would return to your own past. Not symbolically, not in memory, but truly. You could witness your own yesterday. You could arrive before you left. The idea is haunting, but not forbidden. Black holes, especially those that spin, may create such loops deep within their cores. But no one knows what truly waits there. The laws of physics begin to break down. Equations yield infinities. Our understanding falls silent. But in those silences, dreams take shape. Perhaps time travel is not a machine, not a DeLorean or a spinning disc, but a natural shape the universe sometimes wears, like a folding cloth, like a loop in thread, like a breath drawn backward in a sleeping forest. Still, There are paradoxes. If you travel to the past, what happens if you change it? What if you prevent your own journey from ever beginning? These are not just riddles, they are challenges to the very structure of reality. The grandfather paradox, the bootstrap paradox, causal loops. Scientists don't laugh these away, they study them, gently, carefully, like moths held between palms. Some believe that if time travel were possible, the universe would correct itself, that any action taken in the past would already be part of history, that fate is not rigid but recursive. Others think multiple timelines might bloom from such interference, like paths in a forest splitting and winding endlessly. But no experiment has proven these ideas. They remain possibilities, shimmering quietly at the edge of what we can test. Still, the idea endures, that time, like space, may be more flexible than it seems. Let's return softly now to the light, to that quiet beam that has no past or future of its own, to photons that leave the sun and enter your eye, warming your skin, feeding your vision. They are ancient travellers, born in the heart of stars, carrying with them the very signature of time. And though they move impossibly fast, they carry no clocks, no aging, no before or after, they simply are. Light is not just a tool or a signal, it is a guide. It defines the structure of causality itself. It determines what is now, what is then, and what can never be reached. It is the silent enforcer of the universe's pacing, and it is also the messenger that makes sight and warmth and life possible. If we dream of travelling faster than light, we are not simply reaching for new places, we are challenging time itself. We are asking to reshape the canvas of cause and effect. We are asking to see before the light arrives, to act before the moment comes. And perhaps, in some corner of the cosmos, this has already been done. Perhaps there are particles we haven't seen, patterns we haven't understood, machines that bend not with wires and metal, but with space and silence. Or maybe the universe is waiting for us to grow still enough to notice the answers hiding in its rhythm. In the end, light remains our limit, our guide and our mystery. The more we chase it, the more we learn about ourselves, about time and patience and how every motion ripples into eternity. So if you ever feel the seconds slipping too fast or the years unfolding too slowly, remember, time is not fixed. It is shaped by motion, by gravity, by dreams, and perhaps one day, by you. Let us now walk slowly into the quietest fold of this story, where the universe speaks not in bursts of force, but in slow, curved truths. The closer we come to understanding light, the more we find that time is not an arrow, but a fabric, one that folds, bends, and wraps around itself when touched by speed or gravity. This final path begins with the soft truth that we are always moving even when we stand still. The Earth spins, the galaxy drifts, the cosmos expands, and with every motion, time gently shifts beneath our feet. The faster we go, the more that shift deepens. In the deep dark of space, where silence is thicker than velvet and time stretches thin, astronauts aboard the International Space Station experience time differently than we do here below. Just fractions of a second, but measurable, real, quiet proof that speed has hands that shape the ticking of clocks. Gravity too has this touch. In places where gravity is stronger, near planets, stars, black holes, time runs more slowly. This isn't a theory anymore. It's measured, tested, verified. In the high places, time is faster. In the deep places, it slows. The universe whispers its secrets softly, and only those who learn to listen in silence can hear them. Now imagine a clock perched near a black hole, where gravity is strong enough to pull on time itself like a tide. If you stood at a distance and watched that clock, you would see it tick slower and slower, as if it were falling asleep. To the clock itself, nothing has changed. But to you, on the outside, time seems to drip like syrup. This is gravitational time dilation, another fold in the fabric. It means that time is not universal, not absolute, not one rhythm for all. It is personal. It depends on where you are, how fast you move, how deeply you sit in the bowl of gravity. This bending, this warping is not a flaw. It is the nature of reality. Just as rivers curve and winds shift, so too does time bend in the presence of motion and mass. These truths take us back to the question that has quietly followed us since the beginning. Can moving faster than light really allow time travel? Not just forward, which special relativity already allows, but backward, into yesterday, into memory, into history. Here, physics becomes a field of wildflowers, where certainty grows only in patches, and the rest is filled with open space and quiet wondering. There are solutions to Einstein's equations that permit such backward paths. Wormholes, for instance, theoretical tunnels through space-time, may connect two distant points in space and time. If one mouth of a wormhole is moved at high speed and returned, then according to relativity, the time inside that mouth would be different from the one left behind. A traveller entering the younger side could exit at an earlier time, not just elsewhere, but elsewhen. This is not science fiction. It is science, stretched to its thoughtful edge. Yet every time we walk this path, paradox waits. What happens if you arrive before you left? Can the past be changed? Can it be protected? Some scientists propose that the universe guards its own timeline, that any attempt to alter the past would be gently erased by quantum laws. Others suggest that the act of going back would split the universe into separate paths, that each change would birth a new branch, leaving the original untouched. In this view, the past cannot be changed, only revisited in a different stream. But no matter how beautiful the theories, we have yet to witness such a loop. No evidence has whispered from the stars that anyone has walked backward into history, and yet the math allows it. This too is a kind of poetry. That reality leaves the door open for dreams it has not yet fulfilled. But even if faster than light travel and backward time movement remain beyond our reach, the gift of this idea is not lost. It teaches us to see time not as a wall, but as a sea, one that flows differently depending on where we swim. And we are always swimming. Every moment we live, we are falling gently forward in time, drifting on a current shaped by light, gravity, and motion. And perhaps one day, we will build ships not just for oceans or air, but for time. Vessels that bend space-time, that slide through loops or warp space like silk. Not to escape the present, but to understand it. Not to rewrite history, but to feel it more deeply. To walk beside our past selves. To greet the future before it arrives. Until then, we watch the sky and the sky watches us. Light continues to arrive from galaxies that vanished long ago. Its journey is long, but to the light itself there was no journey. It did not age, it did not wait, and yet here it is, painting your walls in golden morning, reflecting in your eyes, warming your skin. This is the paradox of light. It is timeless, and yet it brings time to life. It carries the shape of stars, the breath of fire, the memory of beginnings. Every photon that touches you is a quiet messenger from the past, a whisper that says, "I was there, and now I am here." In that sense, we already touch time. We already live with its echoes. We are bathed in ancient light, wrapped in its slow, soft truths. And perhaps this is enough, to know that time can bend, that it flows differently for different hearts, to know that light carries memory, and that faster than light ideas, even if unreachable, lead us to better questions. That science does not always give answers, but sometimes hands us a mirror, one in which we see not only the stars, but ourselves, curious, dreaming, wondering what it means to move forward and what it might mean to return. So let us not rush. Let us feel the second stretch. Let us listen to the quiet hum of time, shaped by the speed we cannot reach, but forever strive to understand, because even if we never touch the past with our hands, we hold it in our light. And that too is a kind of time travel, not through machines or tunnels, but through reflection, through memory, through light itself. The universe does not deny us this wonder, it gives it freely. Every morning, every starlit night, every glimmer reflected in the eye of someone you love. The speed of light is not a barrier, it is a rhythm, and in moving with it, we do not break time. We learn how to listen to it. There is something almost impossible about a mirror in the vacuum of space, not because it cannot exist, but because of what it might reflect. Not your face or your eyes, but time itself. Light bouncing back across distance, across ages, across the deep hush of forever. Imagine now, far beyond the clouds and satellites, a single mirror floating quietly, untouched by hands, staring into the black. Light, that eternal traveller, races outward from distant stars, and some of it, perhaps only a whisper of a whisper, meets this mirror. It reflects, and in that reflection, time turns around. That is the miracle of mirrors. They do not change light. They simply redirect it. They make it turn back. But when light turns back, time does something strange. Because light has no past or future of its own, it simply is. So a mirror in deep space isn't just an object. It's a quiet invitation to the universe to pause, turn, and whisper again what was once said long ago. Now think about Earth, shining faintly from afar. Every moment it sheds photons, particles of light carrying the story of its surface. A lighthouse, a window, a pair of eyes reflecting the sun. These photons leave and travel out into space forever. If undisturbed, they never stop. But if somewhere far away they meet a mirror, a planet of ice or a sheet of metal on a forgotten satellite, they reflect. They begin their journey home. And if by some perfect alignment, one of those photons re-enters Earth's sky, it carries with it an ancient image, not of what is, but of what once was. This is not imagination. This is physics. The light we see from stars is old. Some of it began its journey before the first trees on Earth, some of it before the first heartbeat. We are always looking into the past. Every telescope is a time machine, every mirror a potential echo. We may never build a machine to send ourselves backward in time, but light does it every moment, in silence. There's a concept in physics called a light echo. When a bright flash from a supernova, for example, illuminates surrounding dust, that dust reflects the light slowly over time. Even if the source has vanished, the reflection lingers, arriving later as if time is unspooling its memory in pieces. Astronomers have captured these echoes, mapping the space around dead stars, watching how time flows not in a line, but in expanding rings of delayed light. Each ring is a whisper from the past, gently unfolding in the present. Mirrors in space, whether accidental or intentional, become part of this unfolding. They're not just passive reflectors, they're record keepers, because if you know how far the mirror is and how fast light travels, you can tell when the light first left. A reflection from a mirror a light year away tells you what was happening here or anywhere 1 year ago. If the mirror is 1,000 light years away, the story it returns is 1,000 years old. The universe then becomes a library of mirrors. Time held not in books, but in beams, not in pages, but in reflection. This idea has inspired more than dreams, it's shaped real science. Physicists once imagined placing perfect mirrors in space to try to catch Earth's own light returning after centuries of travel. The thought is elegant. That light we once let go, candle flames, ancient fears, even moments of joy, might still be echoing out and could someday bounce back. Imagine seeing yourself from 1,000 years ago, not as memory, but as light. It may seem impossible, but in theory it's just geometry, distance and time. The difficulty lies not in the laws of physics, but in their precision. Light spreads, scatters, dims. Space is vast, but even in the improbability, the poetry remains. The universe forgets nothing. Every photon released is a message written across the cosmos, and some of those messages, though faint, may still be returning. Consider now the cosmic microwave background, the oldest light in the universe. It is not a beam, but a glow, a faint warmth stretched across all space. This is the light released when the universe was only 380,000 years old, still cradled in its infancy, and it has been travelling ever since. No mirrors turned it back. It simply moves forward, wrapping around us from every direction like the hum of a distant lullaby that never ends. Astronomers study this light not to look outward, but inward, into the past, into the first breath of space itself. This is what light does. It does not age, it only moves. And by capturing it, even from billions of years ago, we touch the edge of beginnings. And so we find ourselves surrounded by reflections, not just in mirrors, but in time, in thought, in the bending pathways of light. Your reflection in the bathroom mirror is less than 1/1000th of a second old, but it is still a reflection of the past. Light takes time, even in inches. Look at the moon. You see it as it was over a second ago. The sun, over 8 minutes ago. And the nearest star, more than 4 years ago. When you look up, you are never seeing now. You are always seeing then. The sky is a museum of ancient light, and every beam is a time traveller, carrying news from a world that may no longer exist. This is the quiet truth of light. It holds the past gently, never distorting, never forgetting. The mirrors we imagine in deep space, those edges of forever, are not fantasy. They are reminders that time and light, when allowed to wander, always leave traces, always return home, and perhaps, if we are patient, we can catch those reflections, soft, slow, and filled with the stories we once lived and thought were gone. Let's now move further into the shimmering heart of reflection, where science begins to blur with memory and mirrors become more than glass. They become keepers of time's gentlest echoes. The idea of light bouncing back through space may seem quiet and simple, but within it lives a vast unfolding story. To understand it, we must first look at light not as a tool, but as a traveller. Each photon, born in fire or filament, begins a journey, unwavering, guided only by the shape of space and the shadows it must cross. It never looks back. It can't. It only continues forward until it touches something, and in that moment a decision is made. Absorb or reflect. If reflected, it begins again, in a new direction, still at the same tireless pace, a messenger unburdened by weight or thought. This moment of reflection is more than a bounce, it is a redirection of history. The photon's path changes, and with it, the story it will tell changes too. A mirror then does not change the light, it simply offers it another road, another version of the journey. This is how mirrors hold stories, not by storing them, but by letting them unfold again, backward and outward. Now imagine building a vast ring of mirrors in orbit around Earth, an echo chamber for light, curved so that the planet's own glow might find its way back again. In theory, the reflections could circle for years, perhaps decades, before returning to the eye. You might one day see your own childhood, not as memory, but as photons that left your body and wandered through glass and sky, finally coming back home. But it wouldn't be your face as you remember it. It would be as the world saw it, through sunlight, through reflections on windows, through streetlight shining in your hair. Light never lies, but it never flatters either. It captures not the meaning, but the moment. And so in returning, it might offer not comfort, but clarity, a vision of what truly was. This idea, while still a dream, has roots in real science. Some physicists explore light-trapping structures, chambers where beams can be guided to reflect endlessly, creating near-infinite delay. If perfected in the vacuum of space, these structures could become true optical memory, time slowed down through design alone. But we do not need fantasy to see time through light. Every night, sky is a reflection of the past. Every star you see is a history book written in photons. The light from Sirius, the brightest star, left it nearly 9 years ago. The Orion Nebula glows with light over 1,000 years old. The Andromeda Galaxy, a ghost across the void, shines with light that began its journey more than 2 million years ago. And yet, when this light reaches your eyes, it becomes part of now. That's the magic of perception. It transforms the ancient into the immediate. Light, in this way, is a bridge between then and now, between what was and what is seen. We are always living among ghosts, but not the ghosts of spirit or fear. These are ghosts of light, soft and silent, carrying only the shape of memory. This idea deepens when we explore gravitational lensing, when massive objects like galaxies bend light around them, acting as natural mirrors or magnifying glasses. Light from distant sources can travel 2 or more paths around the bending gravity of a massive object arriving at Earth at different times. Sometimes these delays stretch years. A single supernova may be seen twice, once through the shorter path and again when the longer light arrives. These are natural reflections on a cosmic scale. Space itself becomes a mirror, curved by mass and motion, guiding light to echo in strange and beautiful ways. We've seen these echoes. Telescopes have captured them. They are not fiction. They are the universe caught in the act of remembering. Even our own Earth, modest among stars, plays its part. Sunlight hits the oceans, reflects into space, bounces off the moon, and returns again. The Earth's shine you see on a crescent moon, that faint glow on the shadowed side of it, is our own light, returned to us after visiting the moon. In that glow lives an echo of clouds, waves, cities, and trees. We don't often think of it this way, but even that silver shimmer is a mirror, a soft one, gentle and delayed, but real. And it reminds us that reflection is not always sharp and direct. Sometimes it is roundabout. Sometimes it wanders, but even wandering light returns. Even the faintest echo can find its way back. And what of us? The ones who watch, who wonder? Are we not also mirrors? Our minds reflect the world, bounce thoughts back and forth, replay moments like flickering reels of light. We absorb, we store, we reflect. When someone speaks, their words become air, then sound, then electrical waves in your brain. That too is a form of light, not in the visible sense, but in the electromagnetic whisper of nerve and thought. In this way, our memories are echoes. Not perfect, not complete, but real. And sometimes when we speak of the past, we are not just telling stories, we're reflecting light. Dim, distorted perhaps, but still bright enough to see by. The more we understand about light, the more we see that mirrors are everywhere. Not just in glass, but in water, in metal, in eyes. Every surface that shines carries a little of what it has seen. And in that reflection lives time, because to reflect light is to reflect history. To bounce back even the tiniest photon is to give it another chance to be noticed, to be understood. That's what a mirror does. It gives the past another breath. And that breath, when it reaches us, changes how we see, not just the world, but ourselves. So when we speak of mirrors on the edge of forever, we are not only speaking of distant inventions or cosmic lenses, we are speaking of all the ways the universe finds to remember. A puddle on the street reflecting the sky, a telescope catching the light of a vanished star, a memory sparked by sunlight in someone's hair. These are mirrors too. These are the quiet places where light folds backward, where time becomes soft again, and where even the fleeting can feel eternal. In these reflections, science becomes poetry, and the cosmos becomes not just vast, but personal, filled with mirrors that for a moment let us look into the eyes of time itself. Now let us close our eyes and drift gently toward the quietest place this story can take us. Not a place in space, but a soft edge in understanding, where mirrors stop being objects and begin to feel like memories. If light is the traveller and time is the road, then mirrors are the pauses, the still places where something long gone whispers back, however faintly. And in this stillness, a reflection is more than light bouncing back. It is time bending softly inward. The final truth in this journey is not in the stars or theories, but in the strange intimacy between light and return. Imagine this. Somewhere beyond what we can see, far past the cold edges of our solar system, a faint glimmer moves through blackness. It was born here, perhaps from a city window or a child's laughter under a lamp. It escaped Earth and wandered without sound for centuries. Then perhaps it struck something smooth, a passing asteroid with a frozen core, or a satellite long forgotten, and it changed course. It began its return, not because it wanted to, but because the universe allowed it, a single photon finding its way home. If we could catch that photon, read the data carried in its wave, we might see that moment again, not a story told by a person, but by light itself. No memory is more honest than light, no witness more quiet. This is the idea that threads through the fabric of theoretical time mirrors, that perhaps, with the right arrangement of space and reflection, we could look back, not through imagination or recollection, but through photons returned, not into fiction, but into the exact image of a real, lived moment. The science of such a mirror is not here yet. The path is scattered with challenges, entropy, dispersion, the faintness of signals. But even now there are minds building the mathematics, shaping the question, could space be curved in such a way that light loops? Could we create a structure where time's own image is captured, delayed and reflected again? Perhaps, or perhaps the answer lies not in machines, but in the understanding that all light is history, and we are always catching it without knowing. Even our daily lives are surrounded by returning light. Consider how we use mirrors on telescopes to gather and focus the oldest beams in the universe. These mirrors, polished with near-perfect care, take the light from billions of years ago and cradle it gently into an image. That image then enters our eyes, our minds, and in that moment, you are not just seeing a galaxy, you are standing in its past. The light touched it long ago and waited, patient and unchanged, until you were ready to receive it. We do not realize how much patience light has, travels for millennia, without fatigue, without question, never slowing, until it finally finds a place to rest. A retina, a sensor, a quiet mirror in space. This patience is the essence of the universe's reflection. It does not force us to remember. It simply gives us the chance over and over, through every beam, every bounce, every mirrored glint in the eye. And so mirrors, in the broadest sense, are gifts, not just tools of vision, but bridges of time. A mirror on Earth shows you yourself as you were a fraction of a moment ago. A mirror in space may show you yourself as you were years before, and cosmic structures, like gravitational lenses or orbiting clouds of dust, reflect entire stories from when the universe was still young. In every case, the principle is the same. Light leaves, light returns, and in that return, time stands briefly beside us. This idea touches something deep. We live in a world that changes fast, where memory often feels fragile. But light remembers. It holds the shape of every smile, every forest, every fire, every sorrow and every birth. And even though it travels on, even though it leaves, it can be brought back, if only for a flicker. That is what mirrors do. They give the past another breath. And so the sky becomes not just a map, but a mirror. Not just a future to explore, but a reflection of everything that has already happened. When we look out, we are also looking in. There is a theory, quiet and soft, that perhaps the entire universe is one vast mirror, that in the way matter reflects gravity and energy bends light, the cosmos itself is a feedback loop, endlessly reflecting itself in growing, stretching silence. Perhaps the patterns we see in galaxies, in nebulae, in dark matter halos, are echoes, not of sound but of form, of behaviour, of history repeating in the softest language, light. And perhaps we are part of that mirror too, not outside observers, but reflections ourselves, born from starlight, moving through time, bouncing off each other, casting shadows that others may one day see. In the end, whether or not we ever build a perfect mirror in space, whether or not we ever catch a photon from the year 1000, or gaze into the face of a moment long gone, the truth remains, we are already living among reflections. Every dawn is a return of light, every sunset a letting go. And in the dance between those two, mirrors offer us something rare, a glimpse, however brief, of time's gentle reversal, a promise that what leaves is not lost, that even the most fleeting light, given enough distance and patience, may find its way back. So when you next catch your reflection in glass or water, or the silver curve of a spoon, think not of what you see, but of what light is doing. It is bouncing back. It is carrying time in a loop. And even in that ordinary moment, you are touching something eternal. A mirror is not the end of a journey. It is the place where the journey turns. And in that turn, we find something more than science. We find grace. We find that the past is not beyond reach. That time, like light, can be bent softly, and that somewhere at the edge of forever, the mirror still waits. Somewhere in the quiet between seconds, where motion nearly disappears, there exists a thought so gentle, so peculiar that even the universe seems to pause around it. What if there were particles, real ones, not imagined, that move not forward but backward through time? Not because they choose to, but because that's simply their nature, like rain falling or stars burning. They're called tachyons, least in theory, and though no one has ever caught one, the equations that guide our understanding of the universe leave a little space for them. A slim door slightly ajar at the back of time. Unlike light, which forever races forward, always at the same constant speed, tachyons, if they exist, must always travel faster than light, and in doing so they must also live in a world where effect comes before cause, where ripples spread backward, and where time as we know it is reversed. It is an idea that sounds like fiction, but quietly breathes in the mathematics of possibility. To imagine these backward-running particles, we must soften the edges of how we see time. We treat time like a river, always flowing in one direction, from past to future, from what was to what will be. We use it to measure birthdays, to plan seasons, to count footsteps and heartbeats. But in the language of physics, time is not so rigid. It is a coordinate, like length or width, and in certain conditions it can be flipped, like a mirror image. In fact, many of the fundamental laws of physics are time symmetric. They work just as well backward as forward. If you watched two particles colliding and then played the tape in reverse, the math would not object. The universe doesn't enforce a forward-only rule in its most basic grammar. It is us, our memories, our thermodynamics, our limited view, that gives time a direction. Entropy, the slow unwinding of order into disorder, gives us an arrow. But deep down, the equations remain indifferent. Now imagine a particle that lives on the other side of that arrow. It is born in the future and moves to the past. From our perspective, it appears to violate causality, the rule that says causes must come before effects. But from its perspective, everything is fine. It moves naturally, obeying its own arrow of time. If we could watch such a particle, it would seem to arrive before it was emitted, to land before it left, to end before it began. But this is not magic. It is what happens when light is not the fastest thing anymore. Our entire understanding of cause and effect is built on light's constancy. Nothing can outrun it, and so nothing can send a signal into the past. But if something could, if tachyons are real, then the structure of time itself must be re-examined. This idea is not new. It has echoed for decades through the halls of quantum theory and relativity. Some physicists proposed that tachyons might explain certain behaviors in quantum mechanics, where particles seem to influence one another instantaneously across great distances. Others saw them as mathematical ghosts, strange artifacts of an incomplete picture. The word tachyon comes from the Greek tachys, meaning swift, and they are indeed swift, faster than anything we know, but with that speed comes instability. Most models show that if tachyons existed, they would lead to runaway effects, growing without limit, tearing apart the calm fabric of the quantum field. And yet, the door remains open, because sometimes, when the math gives you an impossible answer, it's not wrong, it's asking you to see more. Let's follow a photon now, a simple beam of light, travelling from a star to your eye. It moves forward as expected, taking years or even millennia to arrive. But next to it, invisible, perhaps unmeasured, imagine a tachyon racing ahead, moving not toward you, but away from you into what we would call the past. You wouldn't see it. You couldn't. But if you could, it would suggest that time itself is not flat, but folded. That events are not strung in a line, but woven in a tapestry where threads can loop and curl and double back. And this leads to an even softer idea, that perhaps every moment of time already exists, that the past is still there, the future already formed, and we, like a needle, move through the cloth, one stitch at a time. If tachyons exist, they are not just new particles, they are invitations to imagine a universe where time is not a road but a landscape, where the future does not wait but already is, and where communication across time, not just forward but backward, might be possible. Think of sending a message to yesterday, not loud, not destructive, but a whisper, a warning, a memory from the future carried by particles that flow upstream. This is more than fiction. In some versions of quantum theory, particles can interfere with themselves across time, creating patterns that suggest the future affects the present, just as the past does. These are not easy thoughts. They require stillness. They require the kind of imagination that listens, rather than speaks. Let us pause here with one final image. Picture a quiet forest, moonlit and still. Somewhere in that forest a particle is born, not in a blaze but in a flicker. It exists for a moment, then vanishes. From one point of view it moved forward, decayed and was gone, but from another it entered the world backward, from its end to its beginning. Both views are true depending on your direction through time, and so the forest holds both stories, the forward and the reverse, the particle and its mirror. This is the gift of theoretical symmetry, not to erase direction, but to suggest that more than one can exist, that the universe is not a single story but a duet, and perhaps, if we listen closely enough, we can begin to hear the notes that play in reverse. Now let us drift deeper into the ripple where time no longer feels like a current, but a sea with hidden tides, moving sometimes in directions we cannot name. When we imagine particles that run backward, we begin to loosen the grip of certainty and allow our minds to hold contradictions gently, like two hands cupped around water. In the world of quantum mechanics, contradictions often live comfortably together. A particle can be in two places at once, a state can remain undefined until observed, and the future can, in strange ways, reach backward to shape the present. It is here that the idea of backward motion in time begins to shimmer, not as fiction, but as a possible rhythm, faint but not forbidden. In the double-slit experiment, particles pass through two slits and form an interference pattern, as if each particle has interfered with itself. But when we try to measure which slit the particle passed through, the pattern vanishes. The mere act of watching changes the outcome. Some physicists have suggested that what we call observation may be more than detection. It may be communication with the future. That when we choose to measure, we are sending a signal backward, collapsing all possibilities into one path. That reality is not just unfolding forward, it is coalescing backward too. This thought leads us toward the transactional interpretation of quantum mechanics, proposed by John Cramer, in which particles exchange waves not just forward in time, but backward as well. An offer wave travels forward from an emitter, and a confirmation wave travels backward from an absorber. When the two meet, an interaction occurs. In this view, quantum events are not one-way declarations, but quiet dialogues across time. The emitter and absorber agree on an exchange, even though one lies into the future of the other. And in this agreement, the present is born. It is a gentle vision, not of chaos or paradox, but of symmetry. A handshake, not a scream. This idea doesn't violate causality in the way we fear. It rewrites it softly. Instead of events being triggered strictly by the past, they emerge from a balance between what was and what will be. This isn't science fiction, it is a legitimate interpretation tested and considered by serious minds. And if it holds even a grain of truth, it suggests that backward-flowing information is not only possible but already happening all around us, invisibly, constantly, subtly shaping what we call now. To see how strange and beautiful this becomes, let's imagine something together. A single electron moving through space. In quantum electrodynamics, the most precise theory we have, every interaction this electron experiences can be described as an exchange of virtual photons, some of which may travel backward in time. These aren't particles in the usual sense, but mathematical entities that help explain real outcomes. Still, they hint at a deeper truth, that time symmetry is not just a curiosity, it's a core ingredient of reality. Richard Feynman, one of the great physicists of the last century, once proposed a view of antimatter that resonates with this idea. In his diagrams, positrons, the antimatter twins of electrons, can be thought of as the electrons moving backward through time, not just as a trick of notation, but as a real description of motion. In this vision, every annihilation of matter and antimatter is not destruction, but a meeting of paths from different directions, one forward, one reverse. Each particle carries its own time, and when those times intersect, an event is born. Now imagine a universe where these motions are not rare exceptions but woven into the daily fabric, where particles flit not only through space but across time's layers, moving forward and backward in rhythms too quick to see. Perhaps our own existence is the result of such a dance, not a chain of causes stretching endlessly backward, but a loop, a feedback, a dialogue. In such a universe, the past is not fixed, and the future is not empty. They are both alive, humming softly with possibility. And somewhere in that hum, tachyons may exist, not as messengers of chaos, but as caretakers of symmetry. They might whisper between timelines, preserving the balance that lets the universe unfold with such elegance. Still, the paradoxes remain. If information can move backward in time, what stops us from sending a message to prevent the very event that prompted it? This is the grandfather paradox, where the past is changed in such a way that the future cannot exist as it did. Physicists respond to this not by denying the paradox, but by proposing resolutions that are as poetic as they are profound. One idea is the Novikov self-consistency principle, which suggests that any action taken to influence the past must be consistent with the past already known. In other words, you can interact with history, but you cannot change it. Every loop is already woven. Another possibility lies in the many worlds interpretation, where each backward influence branches off into a new timeline, leaving the original untouched. In this vision, the universe is not one story but a forest of paths, each shaped by decisions, messages, and particles travelling in every direction. And what of us, small as we are, living in a world that feels so linear? Even if we cannot build machines to leap through time, even if tachyons remain theoretical, the fact that time might be two-way, that particles may remember the future, changes how we see ourselves. It suggests that some part of the cosmos is always in motion toward us, not just from behind, but from ahead. That we are not only the result of past forces, but participants in a conversation that spans the full length of time. In this sense, awareness itself becomes a reflection of time's symmetry. Every choice we make ripples backward as well as forward. Every thought is a thread connecting what was, what is, and what could be. We are not only passengers on time's river, we are the river, the banks, and perhaps the rain. So let us rest here for a while, with the idea that the universe is not a clock but a dance. That motion backward is not rebellion, but part of the rhythm. That in the smallest corners of reality, particles may be carrying messages across time, weaving a fabric where beginnings and endings meet, where futures whisper into the present, and where every moment is cradled not only by what came before but by what comes after. The particles that run backward may never be caught, but their echoes already live in the way the world moves, quietly, curiously, beautifully out of step. Now, let us slow even further to the softest hush of thought, where we stop asking what particles do and begin to wonder why time feels the way it does. The particles that run backward, whether tachyons, positrons, or waves folded in quantum silence, are more than theoretical marvels. They are reflections of a deeper yearning in us to understand if time is as simple as it seems. We live forward, we remember the past and imagine the future. But what if we've mistaken the direction of our gaze for the nature of time itself? What if time in its true shape does not flow like a stream, but pulses like a heartbeat? Past, future, each beat containing both directions echoing across the field of being in ways we are just beginning to notice. Perhaps the particles that appear to reverse time are not breaking its rules at all, but reminding us that we have only known one half of its song. When you watch a leaf fall from a tree, you see a process that seems irreversible. The leaf detaches, twirls, and lands. It cannot go back up. But what truly makes this irreversible is not the physics, it's the complexity. On a microscopic level, the laws governing the leaf's motion could just as easily run in reverse. Gravity, motion, inertia, these things are symmetrical in time, but life, complexity, decay, they give time its arrow. It is entropy, the tendency for systems to move from order to disorder, that tells us what is forward and what is not. And yet entropy too is statistical, not absolute. Given infinite time, systems can return to order. Fluctuations can restore lost patterns, and what once fell can rise again. If this is true, then the universe is not so much ruled by decay, but by balance, brief periods of order unfolding into disorder, and perhaps one day curving back. It is within this possibility that the idea of backward-moving particles takes on a different weight, not just as anomalies, but as part of a larger truth. That time is not linear, that the universe is not a one-way unfolding. If particles can move backward in time, and if their motion is not just mathematically allowed but required by deeper symmetries, then everything we know about causality, choice and memory becomes more subtle. Imagine a world where events are not caused only by what precedes them, but also influenced gently by what follows. In such a world, the present is a meeting place, not just of past influences, but of future ones as well. And though we may not feel it, though we may be tuned only to the forward signal, the reverse signal is still there, shaping, guiding, listening. In quantum physics, this is not merely poetry, it is considered. Some interpretations suggest that a particle's behavior is determined not just by its past state, but also by its future measurement. The present becomes a handshake between two conditions, where it came from and where it's going. In this light, even our thoughts, our choices, our dreams may be part of this handshake. We often speak of intuition, of sensing what lies ahead. What if at the smallest level, our bodies are already listening to signals from their own future? Not in a way we can name, but in the way a seed knows how to grow, or the way birds turn before storms. The particles that make us may already carry messages in both directions, shaping who we are from both sides of time. But how would it feel to live in a world where time is not fixed? How would we love differently, knowing that the goodbye is already paired with the hello? How would we dream if we believed that our future selves could send back hope through the quiet rhythm of physics? These are not just scientific questions, they are human ones. The particles that run backward ask us to consider that the world is not a chain of falling dominoes, but a tapestry being woven from both ends, that the threads of time pull from past and future alike, and we are the meeting point in the middle. Even now, experiments are exploring hints of retrocausality, the influence of the future on the present. In laboratories, entangled particles suggest correlations that do not respect classical time order. In some cases, decisions made in the future appear to shape outcomes in the past, as if reality waits to decide until all possibilities are considered, no matter when they occur. Though these effects are subtle and controversial, they whisper a message. The flow of time is not as settled as we thought. Beneath the ticking of clocks and the turning of days, another rhythm plays, one we do not yet hear clearly, but which shapes everything. And so we return gently to the question that opened this story. Can something truly run backward in time? The answer softly is yes, at least in the language of theory, in the curves of space-time, and in the strange dialogues of quantum particles. Whether we will ever harness this motion, send messages to ourselves, or glimpse a memory not from the past but from the future, remains to be seen. But the possibility changes us, it stretches the mind, and opens the heart to a universe not of strict boundaries, but of quiet reversals. A place where cause and effect hold hands across time, where the end of something may also be its beginning, and where even the smallest particles may be time travelers, walking both backward and forward with equal grace. To live in such a universe is not to be confused, but to be humbled. It is to see time not as a line, but as a field, one we cross again and again in both directions, sometimes without knowing. It is to accept that the present is sacred not only because of where it leads, but because of where it echoes from. And it is to remember that what we do now may not only shape what comes next, but also what came before. In this gentle view, every act matters twice. Every kindness, every word, every choice, each is part of a story written forward and in reverse. A story told by light, by atoms, by the strange and beautiful particles that run backward through the soft folds of time. If you were to stretch your hand into a sunbeam, you might not feel it, but you are touching something older than the moment, something that carries within it a story not only of brightness, but of time's quiet architecture. Light does not simply illuminate the world, it holds it together, bending space, shaping moments, and gently writing the rhythm by which time flows. It moves through the cosmos not just as a wave or a particle, but as a constant, a speed so deeply woven into the fabric of reality that all things, everywhere, are measured by it. The speed of light is not merely how fast a photon travels, it is the universe's way of saying this is how time stretches. And in that statement lives a mystery so soft and wide that physicists spend lifetimes chasing its edges. Because when we say light travels, what we are truly saying is, time listens. Consider this. In Einstein's theory of relativity, time and space are not separate things. They are threads of one single fabric and space-time, and that fabric stretches, curves and flexes in the presence of mass and energy. Light, moving always at the same speed, weaves through this fabric like a thread drawn through velvet, responding not to the whims of the objects around it, but to the shape of the fabric itself. A beam of light skims past a star and bends, not because the star pulls it with invisible fingers, but because the space around the star is curved. Light always moves in straight lines, but those straight lines can look curved when space itself is bent. And when space bends, time bends with it. This means that light is not only moving through time, it is defining time's flow. Its unchanging speed becomes the ruler against which all movement is measured. Now imagine yourself far from Earth, drifting in the deep quiet between stars. There is no wind, no noise, no day or night, only your heartbeat and the slow hum of your thoughts. If a clock were ticking beside you and another clock sat back home on Earth, both would seem to tick the same. But if you began to move, fast, very fast, approaching the speed of light, something remarkable would happen. The clock beside you would seem unchanged, but the one on Earth would tick faster. Or perhaps, from Earth's view, yours would slow down. This is not a trick of perspective, it is real. Time itself runs differently depending on how fast you move, and light is the key. Because its speed never changes, it acts as a pivot point. Everything else, space, time, velocity, must adjust themselves around it. And so time bends not by accident, but as a necessity to preserve the constancy of light. In this way, light becomes more than motion, it becomes a sculptor, carving the shape of time itself. The faster you move through space, the slower you move through time. This balance keeps the speed of light steady. And so, when a photon travels from a star to your eye, From a distant galaxy to the mirror of a telescope, it experiences no time at all. From its perspective, the journey is instantaneous. The moment it leaves is the moment it arrives. It lives outside of time not because it defies it, but because it defines its boundaries. Photons do not age, they do not experience before and after, they simply move, and in doing so they carry the shape of the world as it was, painting your vision with the light of long ago events, bringing the past into your present. Now, let's pause and consider black holes. Those silent, dense places where gravity is so strong even light cannot escape. When light approaches a black hole, it slows in a peculiar way. Not in its speed, which always remains constant, but in how it is seen by an outside observer. To someone watching from afar, light near the black hole appears to freeze, to stretch, to grow faint and red as it climbs out of the gravitational well. This phenomenon is called gravitational time dilation, and it shows us once again that light holds the key to how time unfolds. Near a black hole, where the warping of space is extreme, time itself stretches. If you were to hover near the edge of the event horizon, you would age far more slowly than someone waiting for you in the safety of space. And all of this entire bending of moments, is governed by how light moves, or fails to move, through curved space. We see this truth again in the expansion of the universe. Galaxies are drifting away from us, not because they are moving through space, but because space itself is stretching. The light from distant galaxies becomes redder, its wavelength pulled longer by the expansion of the very fabric it travels through. This redshift is a record not of motion alone, but of time's journey. Light becomes the ink that records how much the universe has changed. And because its speed is fixed, every change around it, every expansion, every gravity well, every drift through deep space, leaves a mark on time. Light does not carry clocks, but it becomes one. Not ticking in seconds, but in stretches and shifts in the way its path reveals how the cosmos bends. Even on Earth, we live by this light-shaped time. The GPS in your phone works only because satellites adjust for time dilation caused by their speed and altitude. Without correction, the system would drift, becoming inaccurate by miles each day. Atomic clocks, synchronized with the motion of electrons, rely on the consistency of light to keep our world coordinated. From our calendars to our cameras, our heartbeat to our dreams, light quietly governs how we move through time. And when we gaze at the stars, we do not see them as they are, but as they were moments, centuries, eons ago. We are not seeing the present. We are watching a history formed by the shape of time held in light. So what is time then, if not the canvas on which light moves? Or perhaps it is the opposite. Perhaps light is the brush, and time is the painting it leaves behind. Every beam carries a line, a path, a record. And the world we see is not the world as it is, but the sum of these paths converging in our eyes, shaped by gravity, by speed, by distance. Light becomes our window to the past, our signal from the edge, our guide through the unseen terrain of time itself. Without it, there would be no before, no after, only stillness, only silence. And yet light does not rush. It moves with perfect grace. It waits. It travels across millions of years without changing pace, bringing with it the gentle unfolding of the universe. To hold this idea is to feel time in a new way, not as a rush or a pressure, but as something patient, shaped by the silent presence of light. And in that patience, we begin to understand that our moments are not fixed or simple. They are curved, bent by mass, sculpted by distance, held in the steady rhythm of a photon's path. And perhaps, when we sit quietly enough, we can feel that shape, the way time bends around us, the way light holds it in place like hands cradling water, never quite letting it spill. Let us now float further into this quiet geometry where light does not just travel, it reveals the unseen structure of everything. If space is the loom, then light is the thread, tracing invisible shapes, weaving patterns that make the fabric of the universe visible to us. Light tells us not only where things are, but how they are arranged, how they move, and most profoundly how time behaves in their presence. In every reflection, every shadow, every glimmer, there is a clue about the shape time has taken. Light is not passive, it is a sculptor of perception. The bending of starlight around the sun during an eclipse was one of the first proofs that space could curve, that gravity was not simply a force but a warping of the world itself. When Einstein's prediction was confirmed, it wasn't the stars that had moved, it was the path of their light that had followed the curved road of space-time. In that moment, we saw not just light bending, but time curving with it. The stars told us something deeper still, that what we call straight is an illusion, and what we call time is flexible. If light curves, then time is not steady. It flows more slowly in valleys of gravity, more quickly in the heights of space. The clocks on GPS satellites must account for this, adjusting themselves with every orbit. Otherwise, the signals would be wrong, off by miles, just because time above Earth ticks a little faster than it does below. This correction is not theoretical, it is performed constantly every moment, so that our maps stay true. Light, in its precision, reminds us that time is not universal. It is personal, it depends on where you are, how fast you move, and how much gravity pulls on the space around you. And because light never changes its speed, everything else, including time, must bend around it. This makes light more than a measure. It makes it a boundary, a law, a soft ruler by which all time is shaped. When we talk about distances in the cosmos, we often use light itself as the unit. A light year, a light minute, a light second. But in doing so, we are not simply measuring space, we are measuring how long time takes to move through space carried by light. That distance becomes a memory, a delay, a story caught in motion. A galaxy 10 million light years away is not just far, it is 10 million years old in the way we see it. Its present is unknowable, its light is the echo of what it once was, shaped by the time it took to cross the dark. In this way, every star is a time capsule. Every glint in the night is the past still arriving. And light, moving steadily, never forgetting, brings it to us with perfect grace. Let us imagine again the photon, a single particle of light. It has no rest mass, no charge, and yet it carries energy. It never slows, it never stops. It is born and it moves instantly, endlessly. From the photon's point of view, if it could have one, there is no time at all between its emission and absorption. A photon emitted from a distant star and absorbed by your eye does not age. It does not experience time, and yet it carries time with it, wrapped in its wavelength, in its stretch, in its path. The moment you see it, you see a past that no longer exists, and yet in that moment, it becomes your present. This paradox is not one to solve, It is one to feel, that the past and the present can meet in a beam of light, that time can be folded so gently. In laboratories on Earth, scientists have slowed light down, not by changing its speed, which is fixed in a vacuum, but by passing it through dense substances. In ultra-cold gases, light has been brought almost to a halt. It waits, paused, holding its energy until the conditions release it. This pause is not natural in space, but it shows that even the swiftest thing in the universe can be shaped, delayed, coaxed into stillness. And when it resumes, it carries the same information, the same shape. The photon is patient. It holds its story until the moment arrives to tell it. This patience is mirrored in the cosmos. The oldest light we know, the cosmic microwave background, has been travelling for over 13 billion years, since the universe cooled enough to let photons move freely. That light now bathes the entire sky, soft and uniform, like the memory of a fire long burned out. And from it, we learn not just the age of the universe, but its shape. The tiny fluctuations in that background light map the early clumps and voids, the seeds of galaxies, the scaffolding of what would become everything. In this ancient light, we see the geometry of time itself, stretched across the heavens. The interplay between gravity and light also tells us how time moves in the most extreme places. In the presence of a neutron star or a black hole, light can be bent so severely that it orbits the object trapped in a ring called a photon sphere. Here, light circles forever, neither falling in nor escaping. It becomes a kind of frozen moment, a looped echo of brightness that never arrives. And if we could see it, we would be looking at a stillness that moves, a time that holds itself in place. These rings are not fantasy, they are predicted, and in the case of the black hole and galaxy M87, we have seen their shadow, photographed by Earth's global array of telescopes. The image shows a ring of light, not from the black hole itself, but from the light that nearly fell in and was bent back. In that image, time is shaped by gravity, by curvature, by the fixed speed of light refusing to falter. Even light's colour carries time. As it travels, it shifts. Moving away, it reddens. Moving toward, it becomes blue. These changes are not illusions. They are records of motion, of gravity, of time stretching or compressing. The light from a dying star reddens as its gravity increases. The light from a galaxy receding from us shifts toward the red, marking the expansion of the universe. In every hue, there is a story of time. In every shift, a trace of the path taken. And so we begin to see that light is not just what lets us see. It is what shows us how the universe moves. It is the structure by which time itself becomes visible. Without light, we would be blind not just to beauty, but to order. We would drift in darkness, knowing nothing of shape, of speed, of when. But with it, we can see not only stars, but the spaces between them, and the time it took to cross those spaces. Light brings the past to life, holds the shape of gravity's pull, and maps the curve of every motion. As we end this drift, hold in your thoughts that light is not the fastest thing in the universe simply because it is quick. It is the fastest because it defines speed itself. Nothing outruns it because nothing can. And so it becomes the boundary that bends all else, the pace around which time coils. If we wish to understand time, we must first understand how light moves, because in its motion, time finds its form. let us now ease into the final stretch of this gentle journey, where light becomes not only a messenger, but a quiet keeper of time's most delicate truths. If you close your eyes and think of a sunrise, you're not just recalling colour or warmth, you're remembering a story shaped entirely by light. Every beam that touches your skin has travelled across distance, bent through atmosphere, slowed slightly by gravity, and carried with it the faint imprint of where it's been and how time moved as it passed. In this way, light is a diary, not of words but of wavelengths, not of memory but of presence. And though it has no mind of its own, it brings with it the full weight of what has happened. Even a candle flame flickers with time, its glow shaped by air, by gravity, by the pulse of breath, and its photons, however faint, travel outward forever, recording a moment that will never happen again. This is the quiet magic that surrounds us. Every surface you see, every object touched by light, becomes a soft reflector, a mirror of time. Photons bounce from leaf to leaf, from skin to wall, from window to sky. They remember the colours they touched. They carry the shape of shadows. They take with them a trace of the moment they were born. And though we may never catch most of them, they continue outward, untouched, unchanged in speed, but altered in direction and hue. In this way, the room you sit in is not only filled with light, it is filled with soft, persistent echoes of time, and this same truth scales upward from the smallest space to the entire universe. Galaxies, black holes, nebulae, all of them emit light, and that light maps not only where they are, but when they were. The entire night sky is not a vision of now, but a mosaic of thens. The sky is not a window, it is a tapestry of time stitched in starlight. And yet light does not resist, it moves with perfect patience. It does not hurry, it does not age. A photon created in the beginning of the universe still moves today, unaltered in speed, unchanged by time, carrying the shape of an early cosmos across the endless dark. Some of those photons arrive now, every second, brushing your skin, whispering stories of a universe still glowing with its own birth. You cannot see them. The microwave background is too faint, too stretched, too cool, but they are there, always, like dust of ancient fire gently settling across everything. It is this light that confirms our origins, that tells us we came from heat and expansion and soft spreading silence. And through its shape we learn the age of all things, not in years, but in how far light had to travel to reach us, and in how long time had to stretch to carry it. This stretching of time becomes visible through light's most subtle transformation, redshift. As space itself expands, it pulls the light within it. Not because the light slows, but because the very road it travels lengthens. The wavelengths stretch, the colour fades redder, the energy cools. In that redshift is time's fingerprint. It tells us not only that the universe is growing, but that the journey of light is shaped by the shape of time itself. And so, when we look into the deepest places, when we see galaxies whose light began long before Earth was formed, we are not just seeing distance, we are seeing the curvature of time painted in red. Every deep space photograph is a time lens. Every distant star a message from the past, softened by distance and memory, but still arriving, still speaking. We have even built machines to listen more clearly. Telescopes that see in X-rays and gamma rays in infrared and ultraviolet. Each spectrum reveals a different history. hot, violent light from neutron stars, soft, stretched light from dust clouds, the hidden glow of stars yet unborn, wrapped in their cosmic wombs. All of it travels by light. All of it is filtered through the shaping of time, and through this we have come to know not only the age of the universe, but its possible futures. Because how light moves, how it bends, how it spreads, how it stretches, tells us what the fabric of space is doing and what it might do next. Light shows us that time is not only about the past, it is a map to what lies ahead, drawn not in ink but in motion, in direction, in fading starlight. There is a thought, gentle but persistent, that perhaps light does not just travel through time, but connects it. That past and future are not two banks across which light passes, but two shores it holds together. In this view, the photon is not just a particle, not just a wave, but a bridge. At one end, the star that released it. At the other, the eye that receives it. And in between, a span of time so vast it can contain the formation of planets, the birth of life, the entire unfolding of civilizations. Yet the light remains unchanged in speed. What it connects changes. The beginning and the end shift, but the bridge is always the same. This constancy is not trivial, it is sacred. It means that no matter how time bends or stretches or curves, light will always find its way, always hold its path, and in doing so, hold time itself. So when you look at something, a face, a tree, a cloud, remember that you are not seeing it as it is, but as it was a moment ago. The delay may be tiny, fractions of a second, but it is real. And in that delay lives a truth. All sight is memory. All vision is history. We do not see the world directly. We see the light it sends to us, and that light is always late, always trailing behind the moment it left. This is not a flaw. It is a gift. It means that every act of seeing is an act of receiving. Every glimpse contains the grace of time, and that grace, however small, connects us to everything. To live in such a universe, where light holds the shape of time, is to live gently. It is to know that nothing is truly lost, only delayed. That every moment we live sends out a ripple, and that ripple travels forever, carried by light, recorded in the shape of space. And though most of those ripples will never return, never be seen again, they are still out there, part of the unfolding story, a whisper from now, stretching toward the edge of what will be. So let us move slowly, let us look closely, let us honour the way light moves, not just because it shows us the world, but because it shapes the very time in which we live. Light does not rush, neither should we, because in its patient speed it holds the shape of all our days, and in its unwavering rhythm we find the soft, steady heartbeat of time itself.